Now for the second part of this question we're asked to sketch a graph considering the addition of 25 ml of sodium hydroxide, and we're asked to then discuss, so write something about the similarities and difference between the two curves. So look at how to sketch this graph with the information we already have. Now I've gone ahead and sketched the graph, and now obviously the equivalence point is going to be the same. The reason it's going to be the same is we're still, we've got a increase. Well, we've got 0.2 mole per litre HOBr weak acid, and even though so there's only 10 mils of it, if we've got half the concentration of sodium hydroxide, it would take 20 mils to actually reach equivalence point. So the equivalence point is going to be the same in terms of volume. So that's one of the points we should notice first of all. We already calculated the initial pH would be 4.69, which is what I'm trying to show there. The pKa of this is 8.69. We're given that information, so we'd expect that halfway to equivalence point around the 10 mil mark. And we did the calculation for equivalence point itself at 10.76. So these values will all be different values, and so when we're talking about the differences, we talk about different buffer region, and buffer region is going to be higher. It'll flatten out here, then we'll get it start to rise as it gets closer to equivalence point. And similarities, same equivalence point in terms of volume, and afterwards the only reason that pH is there in terms of what's causing it is obviously the sodium hydroxide, so it's due to the sodium hydroxide in both cases. So that's sketching it. Now let's review the similarities and differences. Now similar in same volume for equivalence point. The pH after equivalence point would expect to be the same. We wouldn't just say that, we'd obviously talk about why, and it's due to the NaOH, the sodium hydroxide. These are obviously both weak acids, although one's stronger than the other, obviously, because it's got a different in pH. And when we look at the differences, the start pH is going to be different in both cases, and that would be a difference. There's different pKa's, so the buffer zone is going to be different. It's going to be higher in the case of HOBr. We're going to have halfway to equivalence point where the pH equals pKa, so that's obviously a difference. The pH at equivalence point is going to be higher in the case of HOBr as well. So those are all differences, and that probably should be enough to talk about the similarities and the differences. The third part of this question is asking to explain why the pH of the HOBr titration curve halfway to equivalence point is basic while the pH is the same point as acidic, and this is just to do with differing degrees of acid-base strength. Now obviously we know that the pKa for HOBr is 8.69, which means leading up to halfway of equivalence point, it's going to have already passed a pH of 7, and then obviously past halfway it's just going to carry on being basic. Whereas with ethanoic acid, it's still acidic at this point here, at halfway. Why is that? Well, this is really just very straightforward in talking about if this is going to be basic here, and it's still going to be basic even before this point for HOBr, what does that tell you about HOBr versus OBr minus? It tells you that if OBr minus is HOBr rather must be a much weaker acid, and OBr minus must be a much stronger base. Whereas if we look at CH3COH ethanoic acid versus CH3 its conjugate COO minus, if we get this being acidic at this point, that means basically it must be a stronger acid and a weaker base. Now to try and simplify this, when pH equals pKa, at this point here we have equal concentrations. Now that doesn't necessarily mean the pH is 7. And in this case, if the pH is acidic, what that tells you is that the ethanoic acid must be a stronger acid, it must dissociate more, it must produce more H3O plus ions. And if we then look at the other case, now in the HOBr case, when pH equals 8.69, we have equal amounts of both of these. The fact is, though, we have effectively a basic pH. What does this tell us? That means that OBr minus, which is the base component, must be producing more hydroxide ions. It's dissociating more, and that means it's a stronger base. Prior to this point, if we still have a basic point, even though there are less OBr minus ions present in solution, they must be producing more hydroxide ions, making it a basic solution. So even though we have more HOBr present in solution, it is not actually producing that much H3O plus or hydronium ions compared to how much the OBr minus is dissociating. So it really is an indication of the acid or base strength. Okay, and you just need to be able to explain that in your answer.